Let's start by talking about, let's see, increasing, decreasing. I think that'll be nice to talk about things. Increasing. You're going to have to use interval notation again. I told you by the time we finished that you would know interval notation, no problem. We'll call this number 1 for today. Okay? So, on a graph, you're doing one of 3 things as you move along your graph. Okay? And let me put a picture up here to show you. When you move left to right, let's see. Let's just do something easy. No. We'll just do a parabola to start with. Whoa. Okay. As you move left to right, because that's the way we read, so that's the way we also read a graph, okay? The function is either going to be increasing, decreasing, or constant. And what I mean by that is increasing means as you move left to right, the graph is going up. Which really means as x gets bigger, y gets bigger. And it doesn't have to get big fast. It can get big as long as it's increasing some. So as x gets bigger, y gets bigger. So then decreasing is just the opposite of that, okay? As you move left to right, what way do you think the graph goes? Down. Wait, so you have to you're going straight across, and I'm going to show you on this example, this here in the middle. So, in other words, as x gets bigger, what does y do? When it's increasing, y gets bigger as x gets bigger. But when it's decreasing, as x gets bigger, y gets smaller. It goes down. Okay? Now, constant is when there's no change. So the only time that happens is when you've got like a horizontal line, right? It's not going up or down as you move from left to right. And so what we're going to do is we're going to describe these intervals. Let me see. Let me put this on a little grid here. And I'm going to tell you that this point, this is the vertex, and I know it's not drawn to scale, but let's say it's 3, 1. Okay? Let's start on the far end, okay? When I start here, as I move across, as x gets bigger this way, what is this graph doing? Decreasing. So on this graph, I am decreasing on the interval. Now here I have to describe it. Okay? So what are the values of x for which I am decreasing? When x is 0, is this function still in decrease? When it crosses that x, is it still decreasing there? Look at the picture. Do you see that this function, when does it stop decreasing? Let me ask you that. This graph. At 3, 1, it stops decreasing. Do you agree? Okay. Do you agree that on the left side of that, it is always decreasing when you look left to right? Everybody agree with that? So, would you agree that it is decreasing from negative infinity forever until I hit 3, right? It's because it left to right, it's constantly decreasing. So it's decreasing from negative infinity until I get to this point 3. Okay? We're going to describe the decreasing and the increasing intervals. Okay? So now look at the increasing part. Let's go now from that point on. Can you see that the function is going up, 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 up? The further I move right, it's still moving up, right? So this function is increasing on the interval what? What's the interval on which it's increasing? In terms of x, look at x. From 3 to what? From 3 to infinity. Increasing, decreasing, left to right. Let me show you a couple examples, and you tell me what the function's doing and give me the intervals. What's this function doing? Increasing? Always? Decreasing? I don't know. You tell me as you move left to right. I'm going up, 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 up. Very slightly still going up, right? It's always increasing. It is always increasing. So this function is increasing on the interval. How do I say always? Negative infinity to infinity. Always increasing. Now, of course, we're going to get into some that do multiple things, that increase, decrease, constant, increase, some of it. This is one of the things we're doing today. We're doing several. You'll label the increasing, decreasing intervals.
Okay, so I have a question. The other one, it was 3 because it had the duplicate?
Yes, yes. And I'm going to show you a couple like that. Look at this one.
That's constant.
That is constant. Why? Exactly. It's neither increasing or decreasing. It's staying the same. It's not going up or down. It is constant. Okay. Yeah, for constant. You can just say the function is constant though for that one. Decreasing where? It's always decreasing. It's decreasing negative infinity to infinity. Say it again. No, you'd still say from negative infinity to infinity. Look at this one. Okay, so give it to me section by section. So you're saying it decreases where? Okay, well, you got to give me an interval. So you're saying it only decreases at -2? You got to give me an interval. Negative infinity until I get to -2. Right? Then it's constant -2 to 2. That's the bracket. It's increasing. That's exactly right. Not hard, right? Y'all are like, it's about time we did something easy. But look, you're using that interval notation again, right? All right. So, we also have, this will be part 2, what we call boundedness. Now, if something is bounded, what is it doing? What's happening? It's keeping someplace where it is, something where it is, right? It's keeping something in a place and it's not letting it go anywhere else. So that's the same kind of thing graphically. We can have 3 scenarios. We can have bounded above, which means there is a point that the graph never gets higher than, okay? Maybe it looks something like this. This is bounded above. There is a point at the top that keeps it from going any higher. It bounds it that way, right? We could be bounded below. Okay, so it's the opposite exactly. So maybe it looks something like, there is a point that it does not go past. Okay, it's bounded below. And then we could have unbounded. Can you think of something that's unbounded? Like a line. A line would be totally unbounded. There's nothing keeping it from going up or down forever. Okay, or even something that maybe goes up on either end. Right, that's unbounded. So fairly easy concept, yes? Everybody good on that? Bounded above, it doesn't go past a point. Bounded below, it doesn't go below a point. And unbounded means it goes on forever. What time's our bell ring? Okay. Let me show you this very last thing and I'm done. Actually, let me just say that when you get into boundedness, that directly impacts your range. Okay? That has to do with what your range can be. Ooh. Okay, extrema, last one. If you understand increasing and decreasing, extrema is an easy concept, okay? These are what we call maxes and minimums, right, Jerome? Sometimes we may call these turning points. Because what happens is the graph stops decreasing and starts increasing, or it stops increasing and starts decreasing. So they're humps on the graph, they're highs or lows, okay? And I'll just take a second to tell you about each kind. Okay. This one, at this point, I hope you can see. You see I'm increasing, 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 increasing. At this point, I stop increasing and I start decreasing, right? Do you think that might be a maximum or a minimum? A maximum. It's a high point, okay? It's bounded up that way. That's a max, okay? Then I decrease, 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 and what happens here? A minimum. I turn again, so it's a minimum. So again, if you understand increasing, decreasing, max and min's a cinch, right? And then I increase, and what happens here? Turning point, it's a maximum. And then, so if it never changes direction, you don't have a max or a min, okay? But here's the tricky part. I have two types of maximums and minimums. I have what I call relative, which sometimes we call local, and I have absolute. Relative means it's a turning point, okay? It's definitely a max or a min, but it's not, the graph is not bounded there. There's a point that's either higher or lower than that particular point, okay? So it's an extrema within a certain area. Absolute means it is absolutely the highest or lowest point on the graph. So when you look at this graph, this first one, do you think that would be a relative or an absolute maximum? Why? That is the highest point on the entire graph. There is never a point that goes above that. It is an absolute maximum. How about this minimum? It's relative. Look at the ends of the graph. The ends, and by the way, your arrows are never extrema. That's just telling you that it's going down forever. So it's relative, yeah.
So if that is relative, then minimum arrow.
It would never go past the arrows. The arrows are going on forever. But it would need to be the lowest point on the graph. If you can find a point lower anywhere on the graph, it's a relative. How about this maximum? Relative. You can only have one absolute. Does everybody hear me? You can only have one absolute, but you don't have to have an absolute. Okay? All right, we're going to talk tomorrow about how to find these values on your calculator, but I am going to go ahead and give you your homework.